The following problems deal with radicals of some sort. In this first one, they want you to multiply and then simplify. So you're going to be using the FOIL method here. First, so I'm going to take 3 times the 2 outside, 3 times negative 1 radical 6. So you multiply the 3 times the negative 1, and the radical 6 is just brought along. And then positive 1 times, positive 1 radical 6 times 2. You multiply the number part with the number part, so you're going to get plus 2 radical 6. And then if they're both under radicals, you multiply the numbers in front, 1 times negative 1, and then square root of 6 times square root of 6. You multiply the radicands together. So if they're both under radicals, you can multiply them together. And then simplify and combine like terms. So I have a 6, a negative 3, and a positive 2 radical 6 is going to add up to a negative 1 radical 6 minus 1 times the square root of 36 is 6. So I have 6 minus 1 radical 6 and then minus 6. When I add the negative 6 and the positive 6 together, those cancel out. So ultimately, I'm left with just a negative 1 radical 6. Okay. For the next one, you're solving for x. So you want to get the radical on one side by itself, the constant on the other side. Since this is a square root, I'm going to square both sides of the equation. If this had been a cube root, then I'd be raising both sides to the third power. So whatever this root is, that's the power that you'll raise to both sides. On this side, the root and the power cancel out. That's why you pick the same number. And I'm left with just the 3x minus 2, no more radical, equals 25. And then solve for x. So add 2 to both sides of the equation. 3x equals 27. Divide by 3. And you get x equals 9. Whenever you square both sides of the equation, you do need to check your answer to make sure that it works back in the original. So we're plugging in the 3 times the 9. The 9's what's getting plugged in here for x, minus 2. That's supposed to equal 5. So that's what we're checking. Square root of 27 minus 2 is the square root of 25. And the square root of 5 does equal 5. Okay, so we got the square root of 25 was 5. And it equaled the right-hand side. For this one, we're simplifying. In other words, they want me to subtract the 2 radicals. In order for you to subtract or add radicals, the radicand part has to be identical. So if they're not, you'll want to see if you can simplify it. So for example, this 50 can break down into 25 times 2. Now the reason I picked 25 is because it's a perfect square. Notice these are your perfect squares. 2 times 2, 3 times 3, 4s, 5s, 6. It's not writing so good. 7s, and so on. So the first number that I'm picking is a perfect square. And the reason I want a perfect square is because when I break this up, square root of 25 times the square root of 2 now, square root of 25 is 5. And I'm going to do the same thing with 18. What number on this list will divide into 18 evenly? And I want it as big as possible. So the number 9 is my number. So 9 times 2. So I still have the minus 3 in front times the square root of 9 times the square root of 2. The square root of 9, though, is 3. And I can multiply negative 3 times 3 together. So I have a 5 radical 2 minus 9 radical 2. And now that the radicands are the same, I can go ahead and subtract the numbers in front. Negative 4 radical 2.